the story of the code. An epic tale of stuff. So, it's Saturday, it's been a long week. We're tired, I'm tired. I figured something a little bit more lightweight, easygoing, that you can kind of, pretend you're listening to intently, but actually have your eyes closed to sleep. It's certainly going to be more easygoing for me. A quick disclaimer, this is a bit of a last-minute addition to the schedule. So we may run a little bit short. The good news is we're not going to overrun. But, we're going to be out for lunch plenty of time. Except these 90-minute sessions are supposed to be 60 minutes talking and 30 minutes of Q&A. Actually specifies that when you submit talks. And if you're in the lightning talks last night, you'll know the Q part is normally small. In fact, I think the Q part was smaller in the lightning talk. And the A part is this, assuming that is I have any A's for you at all. And if I was to do a full 90-minute talking at you talk, we would just have A. So we don't actually want to hit full 90 minutes with the talk. That's not good. I'm rather hoping this session will generate questions, so I'm hoping more for Q and A, and maybe some discussion and questions. And besides, this whole subject really has no easy answers. So, in fact, the next 90 minutes may end up just looking like this. Rather than falling short, though, this is a good thing, because if it's generating interesting questions and generating discussion on a topic that affects us all, then actually I view that as a win. This session is not going to provide you with easy answers, silver bullets, unicorns, various other stuff. This session is going to provide you with a story, and that is the story of the code, or at least one of the myriad of stories that is out there. So, epic tale needs an epic opening. This particular tale did not happen a long, long time ago in a galaxy far, far away. So we're going to stick with a more traditional opening, once upon a time. Once upon a time, there was a young programmer who decided to satirize programming. He codified this as such: real programmers don't comment their code. If it was hard to write, it should be even harder to understand and modify. Real programmers don't document. Documentation is for simpletons who can't read the listing or the object code from the dump. Real programmers don't eat quiche. They like Twinkies, Coke, and palate-scorching Szechuan food. Can't say I've ever had a Twinkie. Do like Szechuan food, though. Very nice. I've also been known to eat quiche on occasion, which may or may not damage my credentials for this session today. It's important to note that I am an incredibly picky eater, so I have opinions on quiche. I may or may not eat any given quiche that you give to me. This is unrelated to me being a programmer, my skills as a programmer, my ability to give this talk or otherwise. I just thought I'd better pop that out there. Not all quiches are born equal. This is a sweeping statement. Now, these sage snippets of advice form some kind of document called Real Programmers Don't Eat Quiche, which, if I'm correct, hails from 1984. A year conspicuous insofar as it was nothing like 1984. 1984, it would appear, is happening some 4 decades later, kind of now-ish. We just decided we would carry the cameras and the microphones in our pockets. You may or may not find this double plus ungood. Despite being a bit of early internet humor, important word there is humor, it is surprising how some of this quote-unquote advice, how some of these gems appear to have become real bits of advice. And the tale of how this happened is a really long and sordid tale, with things oft repeated in all areas of development, and it gains a momentum in a life of its own. And this has happened throughout history with many things. People, for all of their randomness, assuming randomness exists, see Fran's talk from earlier in the week, people tend to be remarkably predictable as a large group acting over longer periods of time. But to quote the great late Douglas Adams, this is not their story. But let's look at what's dropped out of that story in a little bit more detail. Real programmers don't comment their code. Well, yes, there are a lot of people out there who are real programmers. We can decide that they are real for a given sense of real, and they don't comment their code. This is a thing, people do that. There are also real programmers who write comments. These comments may or may not be good, they may be useless, they may be pointless. And there are real programmers who write good comments. And I'd wager most programmers at various points in their career, or possibly various points in the same day, have been all three of these real programmers. And I doubt programmers become any more or less real as the day progresses. I don't know. I have visions of the Back to the Future, looking at the photograph of the programmer fading out of his picture. I am less real. I've written a comment. And what do I even mean by real? Other than programmers who don't have an imaginary component, I suppose. Honestly, unless we start making changes to the text we've got here, it doesn't even really make sense. So some programmers don't comment their code. This is much more accurate. And actually, if we wanted to be really precise, some programmers don't comment their code at all. Some programmers don't comment their codes some of the time. In fact, I would wager that most programmers don't comment their code some of the time. But we're going to bring back some of the implied stuff, because otherwise this slide is going to get really, really messy and end up with an FC me at the bottom. So we'll go back to this. Some programmers don't comment their code, and we'll just imply the other bit. If it was hard to write doesn't even come close. I've shed little blood, sweat, and tears in my job. And my job has always been the creation of software. And I suspect tears are remarkably more common than people are willing to admit. Certainly in my career, there have been more than one occasion where there's been tears. Sweat and blood, actually, yes, that's also come through. The blood comes from me building furniture for a small startup. I was putting together the tables and the Kallax furniture. And while this is not directly related to writing the software, you kind of need to have somewhere to put the developers. They need an enclosure or a habitat, otherwise they don't thrive. So it becomes part of the very early development process, produce the environment. And it turns out that Kallax, the big Kallax shelves, are surprisingly heavy. As you're putting together, you work up a surprising amount of sweat, which makes one's hands very slippy. Anyway, long story short, there wasn't much blood, there was a lot of sweat, and there weren't any tears at that particular time, but there was an awful lot of swearing. It didn't mean that the Trinity was completed, though. We'd had the blood, sweat, and tears. So, I mean, hard to write is just an understatement. You're trying to get requirements from people who don't actually understand what it is that they want and don't understand how to speak to programmers. And you've got the programmers who may be talking to the people who don't understand how to talk to the people. And then you've got the program that needs to go out into the... It's just an absolute mess. We're all at loggerheads. Hard to write is just an understatement. Some programmers don't comment their code. If it's hard to write, it should be even harder to understand and modify. Well, the dumbest statement I've ever heard one. I don't even know where to start with that. I mean, it sounds really impressive. I write hard to understand code. You are going to find it hard to modify. But it also actually makes you just sound like some kind of an idiot. You know, talk about cutting your nose off to spite your face. If you want to make your life difficult and the life of everyone around you difficult, then knock yourself out, go for it. I mean, who am I to say what do you do? But I don't want to work on your team with you, because I've been in those situations. In fact, if you show me a developer who believes any of this stuff, I will show you a team with systemic and endemic problems. This paragraph isn't a brag. This paragraph is actually a huge red flag. So let's park our red flag just for a little bit. And let's go have a look at some code. So this is Go. I do Go. I'm not a C++ developer. I'm an imposter. This particular piece of Go has a thick Java accent. We'll come to that later. And we're defining a function called getName. Returns a string. I've omitted the package definition for clarity and where we're getting name from and everything like that. The function body is returning a variable that must be a string because Go is strongly typed, and therefore it's got to be a string. And there are a lot of problems with this particular code snippet because the Go compiler, actually there's not problems with this for the Go compiler, but the code snippet has to be written like this because the Go compiler is incredibly opinionated, something that I like. If you don't want an opinionated compiler, I would suggest a different language. Personally, I love it because it removes a whole set of arguments, a whole set of cognitive overload, and you don't have to worry about it. You use tabs, not spaces. But honestly, this is a dead argument. My IDE does this for me. I cannot remember what button I press, or even if I press the same buttons. I make an indent. The IDE makes sure that it's the correct indent for the language I'm using. Camel case, first letter dictates scope. So if you want public scope, it's a capital letter. If you want package scope, it's a lowercase letter. If you don't like that, pick a different language. Your braces go on the end of the line because only an idiot would put them anywhere else. I used to work with a code where the braces went on the next line, and I did that because only an idiot would put them anywhere else. I suspect if you had a different brace format that I worked with for long enough, only an idiot would do it any other way. It doesn't really matter. I know Kevlin has strong opinions on this, but I think his argument is actually flawed there. I need to take that up with him one day. No semicolons at the end of the line. I even wrote a joke language about this called colonoscopy, where all the missing semicolons from different languages are used. It's a row prime for non-expletive versions of the code. There's a row prime variant. You've got a program called GoFormat, which says how the code should be laid out. And it's not necessarily enforced by the compiler, but I enforce it through my build pipeline. And then there's other things like Go imports. And I run it through GoLint, I run it through the metalinter. And they're not hints, they're not warnings, they're not kind of, you should do this, you do it, or you don't. It's as easy as that. So I love this. This is great. But this will compile with the compiler. But if I lint it, the linter complains that getName should have a comment or be unexported. Okay, fair enough. It's public scope. People will be using this if they're using any of my my code. Therefore, I should probably tell them what this does, why it does it. And the Go linter, like I say, does not warn. It's not a suggestion. Make it happen. The Go linter also wants the comment to be in a very specific function, so the documents with Go are built from these comments. So it needs to begin with the function name. It will allow other things in front, like a, the, what have you, but basically function name. And the Go linter is also incredibly dumb. So this is fine. This is yes. We could go a little bit better than this. I've actually got extra linting that makes sure you've got a full stop on the end of the line and various other stuff like that. So we'll pretend we are at least trying to fix the problem and write something that's borderline reasonable. So getName returns the name, and Captain Obvious is obvious. This is worse that when you consider that unlike Java and other languages, Go tends to dispense with the useless warts on names, so this really should just be name, where the comment becomes name returns the name. And Captain Obvious is even more obvious. No wonder we're not commenting our code. This is just pointless. This is just typing. So, I don't know, maybe we shouldn't be commenting our code. We'll see. Real programmers don't document. Documentation is for simpletons who can't read listing or object code from the dump. I'm very glad there's an or here, because I'm not entirely sure what the object code from the dump is, or how you would even go about getting it from the dump. This may or may not say something about my ability to program. I don't know. I do go. That said, I can't actually remember the last time I saw a core dump, so we'll pretend this statement has simply just become outdated or doesn't apply to my particular programming language, and simply implies that if you've got access to the code, then you don't need documentation because you have the code. The code is the documentation. And by all means, feel free to judge me and feel superior because you know what an object dump is and how to get the stuff out. But really, I'm very blissful in my ignorance here. I would argue that having to deal with the object code from the dump is probably a process failure, and not as in your process has failed, as in your software process has some issues that means you're having to go right into the nitty-gritties rather than dealing with it much further up in the process. So at this point, I'm going to turn to JavaScript because JavaScript is the gift that keeps giving. Create React app. Caveat emptor, this is 2019, I think I did this. So things may have changed, but this was the state of the world in 2019, in the before, if you can remember that time. So we do create React app, and it goes off and it installs some packages. And apparently this may take a couple of minutes. And Dom does react to this. Yes. Eventually, we've downloaded the entire internet, and we can start hacking. So for shiggles, let's try this. What we're going to do here is we're going to find every file called package.json. We're going to print that out, and we're going to count the number of times it's found that particular file. So this should give us a rough indication of the number of packages we've just pulled. Working on the fact that we've got a package.json, and there is a package there. What happens here is we find out that there are 1,589 packages that have just been pulled down in order to create an empty React app. The reason I haven't done this in a tree view is because it doesn't fit on the slide in any way, shape, or form. So yes, life could have got better in the intervening few years. I doubt it. For a laugh, once I had all the package JSON stuff, I decided to dump all the information from those into a graph because I love graphs. So I threw it into my favorite graph database and had a poke about. And it is scary how many packages are included more than once. And there's multiple versions of those packages. And they are very disparate versions of the packages, so the release dates can be very, very far apart. So it is little wonder that LeftPad broke the entire internet. This whole thing is dependencies upon dependencies upon dependencies. And this is, of course, JavaScript. We're mocking JavaScript. So let's go and see how many lines of code we've got. There's clock. I think that's how you pronounce it. C-lock, I don't know. Count how many lines of code you have. So, bam. No, it's not just JavaScript. It's TypeScript and CoffeeScript. And we have 1,259,920 lines of just JavaScript. That's some. I'm not entirely sure I could go through and grok all of those if I needed to go find out how something's working. Big brain, not that big. There's also TypeScript and there's CoffeeScript. Also, apparently, there's some C++. Ooh, I've got some C++ in my talk. There's some D in there, apparently, and some Lisp. I don't know what they're being used for. They may be supporting tools, but call me a simpleton. I am probably going to need some documentation here just to help me along just a little bit. Again, if you want to judge, feel free. I'm happy with that. And we don't have to go to such extremes to actually realize that simply having access to the source code is not enough. So back to our name function. Here we go. We are now returning the name in what I believe to be title case. So to title, I'm thinking this is going to give me title case. But what does that actually mean? We can realize that toTitle is from the standard library. The standard library is actually quite well documented. So let's go have a look. And in fact, in my IDE, I can just click through it. It takes me through to the function, and there we go. toTitle returns a copy of the string S with all Unicode letters mapped to their Unicode title case. Cool. The source really isn't much help here, because this calls another function with the variable I don't actually know the value of, Unicode to title, and I'd have to go into that, and I think that actually calls another function, and it's turtles all the way down. So I kind of need to rely on this particular piece of documentation to tell me what this does. So I can throw together a little test program, turn my name function into a program, importing a few things. We're going to use Old MacDonald as a name for reasons, and we're going to just print that out via the name function. And what we get, well, actually, before we say that, let's just go through. For those who haven't done main, Go, package main, special package, entry point of the program, func main, special function, entry point of the program. And all we're doing here is calling name and putting that out to the console, format println, very similar to C and other similar languages. And name is just our standard name function where we are calling to title, which I believe is going to give me title case. So we can bring up a terminal and we can go run name. What this is going to do is compile it for me and then run the output. And we get, boom, that. Not what I was expecting. Like genuinely, when I was putting this all together, not what I was expecting. And I'd read the documentation. I'd read what it said. So it turns out that we suck at documentation too. And this is a double-edged sword because it's not just that we suck at writing documentation, we suck at reading documentation. I read what they said. It said it turns every character to its Unicode uppercase variant. It's not the first character, every character. This is exactly what it said it was going to do. And yet I was genuinely surprised because I had read the documentation. Or had I? So, we suck at documentation. Genuinely. What else do we suck at? Commit messages. We're useless at commit messages. Initial commit is probably the worst commit message in the world. I mean, it's very descriptive, but not at the same time. And yet, it is part of almost every single code base I have ever created. And I'm pretty sure I didn't invent this practice. I'm pretty sure I copied this off someone else. And I'm pretty sure this predates Git. The reason why we have commit messages is to tell the world, or at least the people who are looking at our code, why we've just written what we've written, or what we're doing, what's happened in this particular bucket of change. So what should we be putting for an initial commit, and what should it actually contain? I mean, perhaps our initial commit should just be a README that contains the repo name as a title. I don't know. Could be. But despite that being fantastically simple, there's a whole load of context that just appears out of nowhere. Why are we using Git? Why that particular name for the repository? What is the repository going to do? Why did we decide we needed a new repository? Wait a second. There's a story here, and one we've utterly failed to tell. Initial commit isn't the start of the software development process. It's not the start of the story of the code. It's not even the opening line. It is not once upon a time. It's more like chapter 3, coding begins. So for a while I had this as a base repository. Honestly, I'd completely forgotten about it. But it gave me a simple makefile, and my initial commit could be a README and stuff like that, so I could run the install and it would dump the two things there, do a couple of other bits. And well, hey, I could go git commit, git add, and commit in and an initial commit. And then for a while I decided to just lampoon things and say, a wild repository appears. But this bakes in even more unspoken information. Why am I using make? What's behind the language decision? Why am I using Go? What were the discussions that we had before we even got to this particular point? Oh, and how the hell did this even get 3 stars? I have no idea. I found that repo we're just looking at while I was looking for this repo, because although this is now deprecated, at the time when I first wrote this talk, this was the repo that I was using to create my initial README and everything. And it was a lot more complex. It provided config for my linter and various other bits, so the pipeline files and stuff like that. There's a license in there. There's a standard ignore file that I use. A whole bunch of things that just make my setup easier. And everything in this repository just raises more questions, some of which are really, really subtle, like why did I move from Git Hub to Bitbucket? Don't know if you spotted that, but this is Bitbucket. The previous one was GitHub. What's really mind-bending is if I use this repository to create a new repository, then the initial commit for that repository comes from a repository that itself contains an initial commit. So we are turtles some of the way down here. So this repository must actually be some form of a prequel. And it turns out it's not even the first book. And now my book analogy is really breaking because real world has made life way too complicated, as it has a tendency to do. And I've since abandoned that project for something more generic because I'm a developer. Ooh, shiny. It's kind of what we do. There's also many, many untold stories in this particular thing, and I suspect I've forgotten the details for a lot of these stories. Let's stop looking at the code and instead look at me, because I'm autistic and I'm my favorite subject. Hi, I'm Dom Davis. I'm CTO and co-founder of Tech Marionette. Now, as a statement, that conveys far more information than initial commit ever could. But it doesn't even begin to uncover my story. And where does my story even begin? Does it begin at my birth? Does it begin at my conception? Do we need to look into the story of my parents at all? What about their parents? How much detail do we need to include in my story? Ultimately, my story is the story of everything, beginning with the Big Bang, and ending at that maximally entropic state in which we have the infinite distribution of tiny little particles homogeneously spread around a spaceless universe. The story of any codebase is similarly as complex. Thankfully, as a species, we have invented the art of storytelling. We're able to construct a narrative that includes only what's needed to convey the essence of the story, and then happily excludes the rest of the universe. And I notice it's an art. It's the art of storytelling. It is an art, and it's one that can be used to perform very different roles. Stories can be used to teach, they can be used to inform, they can be used to educate, they can be used to entertain. But they can also be used to manipulate and to misinform and to misguide. Whatever your views or your beliefs, it's easy to see that narratives can actually be a very, very powerful tool. It's our blessed homeland and their barbarous wastes. Our glorious leader and their wicked despot. This is actually something I learned at quite a young age. I grew up in the Middle East. And in the summer, it got very hot, so we had very long summer holidays, and I would fly back to the UK to stay with my dad. And I would leave Bahrain, and we would see on the news that the Palestinian freedom fighters had struck a blow against the illegal Israeli occupiers in the Gaza Strip. And then you would come back to the UK, and you would hear that the Palestinian terrorists had detonated a truck bomb, and that the Israeli army had targeted some terrorist bases. So at an early age, I realized that there are three sides to every story, their side, and the truth. And it is generally somewhere in the middle. This happens everywhere. And we are all guilty of it. We need to be aware of that. So as narratives go, initial commit isn't the best start in the world, especially when initial commit is the only commit. Something that I have actually been guilty of in the past, and a past that is embarrassingly quite recent. What are we saying with a single initial commit? We are saying, here is something I have painstakingly created where the creative process has been entirely hidden from you. My story becomes once upon a time, happily ever after. This is from me in 2019 at initial readme.md. Slightly better than initial commit. You'll note the blissfully happy and smiley profile picture that I've got there, unaware of what is around the corner. 2019, 31st of December 2019, I think we all remember what happened shortly after that. Yes. And dump a bunch of stuff in the repository in a single hit. Okay, so I am lampooning the fact that this is a crap commit message, but that doesn't stop this being a crap commit message. I knew I was doing the wrong thing here. I've been bad, and I know it, and I've been caught. So maybe we shouldn't be telling the story of the code in the git commit messages either. Although that does beg the question, why do we have the commit messages in the first place? Which leaves us with kind of a problem. Where should we be telling the story of the code? The answer is everywhere. The story of the code is written in mixed media, and there is a term you probably haven't heard since the 2000s. And also relies heavily on context. So let us tell the story of the code. Once upon a time, there was a sole developer who was writing primarily in Go. That developer liked to keep things in neat, self-contained packages, but found that each time they created a package, they had to do the same thing. So they created something that did it for them, because they're a developer, and that's what developers do. Due to historical pricing models, the developer used GitHub for their open source stuff. So they published the package there, because this was open source. Those same pricing models meant that that developer was using Bitbucket for work and was dabbling with GitLab and its pipelines in their spare time. One day, Bitbucket gained pipelines, and changes in the pricing model meant that the developer started preferring Bitbucket over GitHub for their projects. They had also discovered the Go metalinter and the use of Go modules, so they decided to create a new base project that helped this new, more unified world that they occupied. I know this story because I am the developer. In fact, I'm the only developer who's worked on this code, so I should know the story in its entirety. Except I don't. At some point, I had clearly forgotten that this thing even existed. The story had started disappearing. And the fact that I found it researching this talk meant I'd not remembered where I'd put my base repository, because I had to go looking for it. I'd forgotten that there was another base repository in another source code control system entirely. This code isn't used much. Time and distance starts eroding memory. And there is a question I can't answer. Was the new base repository used to support an improvement of the old one, built from scratch? Well, we can find out. Let's go spelunking. Oh, look, initial commit that formed the repository with everything in it, all added. So I can start looking at the files and perhaps seeing if there's a common link between the ones in this repository and the ones in this one. And I can check diffs, but they're hard to check because they're not actually in the same Git repo, so now I've got to download 2 different Git repos. And I'm doing code archaeology on code that I wrote myself not all that long ago. The initial story of the code is gone. All those moments will be lost in time, like tears in the rain. And there's actually more to that story as well, because GitHub has gained the equivalent of pipelines. And their pricing model means I could go back to them. But actually, I'm stuck with Bitbucket because I use it for work and I kind of like it. Shoot me. So why not just do everything in one place? There's a reason I'm doing it. It may not be a good reason, but there is a reason. It's part of the story. Now, does it matter? Does it matter that I don't have the full story of this repository? Maybe, maybe not. Possibly not for this repo, I don't know. But I'm doing it all over again with its replacement. And this is after I've done this talk once already and sat here and said this is what we should be doing. I've stood in front of an audience and gone, this is a bad idea. I'm not even practicing what I preach, so why even try? What is the point? Now, when you're faced with a sprawling legacy code base, knowing the story of the code can actually help with that age-old question. Who the hell wrote this? Full disclosure, I didn't actually write this joyous snippet. This was taken from the daily WTF many years ago. It's one of my favorite ones where we're defining bool as true, false, and file not found. There is a story there. Who the hell wrote this? We've all thought it. We may have even said it out loud. I know I have. And it says a lot about our journey as a software developer. The statement tells a story in its own right. Wow, it says. Look at the state of this code. Only an idiot would have written code like this. And it's fun when that idiot turns out to be you. And that has happened on more than one occasion. Especially if that idiot happens to be you only a couple of months ago. So like I say, this particular doozy isn't mine, but I have been guilty of very similar style things. My entire career has been full of who the hell wrote this, and the who being me. Part of the reason I like doing code reviews with junior developers, because you can't sit there and assume that they understand everything that's going on and have all the contents of the knowledge that all the senior developers have baked in. You actually have to go down and break it down a little bit more, start explaining stuff in more detail. And I have lost count of the number of code reviews where I've been and gone, right, so this does this, this does this, this does this, ooh. Right, we failed this review. Go fix the issue that we have just found because this does not do what I thought it was meant to. And I'd much rather have a little learning moment like that for both me and the junior developer than to have the shouting moment in production. Don't like them. They're not good. But who the hell wrote this is entirely the wrong question. We've reached for the blame game. Blamestorming is a wonderfully fun practice. It was him. And I have actually been in a true blamestorm where someone has come up to me and gone, give me a name or you are fired. There was that much money being lost that they didn't care about lawsuits. So you instantly go, it was them. And hope that you have dodged the bullet. We shouldn't be playing this game. This is a confrontational game that builds bad teams and bad blood. Here's a much better question. What don't I understand about the context of this code? What is the information that I am missing? What do I not know about the story of this code? Which chapters have I not read? Let's look at a really simple simple example. If you look at this, I look at this, this is an instant code review fail. There's a couple of issues here for me. It's an empty function. Why do we have an empty function? There are times when an empty function might be useful, but in this context, it doesn't really spring to mind. And I can't work what it does because there's no documentation. So no documentation, no code. Why is this passing code review? And which idiot committed such pointless code into a code base? Me. I did. I let it pass the code review. And in fact, I pulled rank to force it through code review. The code has been changed to protect the guilty. Even the language has been changed. But the original function, before I got my hands on it, took a session object and then dumped that session object into a comment in a web page when a 500 error was happening. So you could right-click, look on the 500 page, and see the contents of the session. Which is great, until you realize that the session is outputting a lot of stuff you didn't realize it was outputting, like sensitive user information, like the credentials to our merchant banking account. And if you wanted to see all of this juicy data, all you needed to do was cause our application to have a 500 error, which was laughably easy, view source, and you'd hit jackpot. Now, as far as I'm aware, mercifully, no one had discovered this flaw yet. But I was suitably panicked, and I wanted to fix out there ASAFP. And this is one of those occasions where I did actually hit the big red switch. I just killed all the servers. Shut the entire site down, got a fix out in seconds, got that going out. Now, you might say, great, why not just stop this function from being called? Right, all you need to do is just stop the function from being called and then we're good. And I'd love to have had that option, but this code uses dependency injection and a bunch of other magic that we really didn't understand, and it meant I had no idea where the call sites were. In some cases, I wasn't entirely sure how this got called. So I could have spent a lot of time doing code archaeology and trying to understand what's going on in a hideous code base that was literally held together with bits of blue tack, a string, and a strong sense of optimism. I didn't think that was the best fix for this. I didn't have time to go spelunking hundreds of thousands of lines of poorly documented and hacked together code in a badly architected application. So I made it a no-op. Do nothing. Now, this could cause other issues. But in my mind, the unforeseen consequences that this may have are going to far outweigh someone being able to get hold of our merchant banking details. So function lobotomy happened, and hopefully this is less problematic. Perhaps I should have documented, but to be honest, the linter can go take a flying leap at this point because I don't want my build to break. I need this out, and I need it not to do anything, so stop linting. I'm flying blind, I have no idea what this does. So let's just get this out. This is a hack. I know it, you know it, everyone knows it. This is not pretty. This is going through the release process because it needs to. And while it's going through that, once I've done the emergency fix, I can then start calming down and getting the issues together that I need to say to fix this. Let's do it in a less hacktastic fashion. Is there another thing? I have a question from the floor.
Why did you take the effort to type no lint when you could have taken that same amount of effort to type why you're doing this?
That is a very good question. I was panicking at the time. So for the benefit of people watching this, the thing was, why did I type in no lint but not actually put any documentation and stuff in there? And I also have another reason for that. Yes, this is going through the build pipeline. I'm going to do something slightly less hacktastic and get that out later today, maybe in an hour. And then something else behind it that is a better fix. Which idiot did this? Well, that idiot may have just saved the company, I don't know. And it allowed you to continue having a job, perhaps. So maybe that idiot wants to be, or maybe you need to be less judgmental about that idiot's code. Although, if this is the whole story, then the idiot moniker can stay. Absolutely. Arguably, this would have been a better fix. Okay? But I didn't want unintended build failure, so I wanted the no lint in there. Fix the emergency and then make the fix better. Also, let's not mask this. Let's not pretend it's something better than it is. Let's leave it there as a great big steaming pile that begs all kinds of questions if, for whatever reason, because it happens, you don't go back and make the fix. Let's make this stand out like a wart. This is something that needs fixing. Okay, now, I fully agree that something like this needs to come in later, but we can do this when there isn't an emergency, when I can test things, when I'm not so worried about my future employment, and we can start looking at doing things slightly better, like maybe using loggers and other things that we should be using. There's a whole bunch of stuff that got raised from this, a whole load of work. So, moves the question. Let's brainstorm. Which idiot did this in the first place? Which idiot made it so that we were dumping all of this sensitive information to the 500 page? And I'm going to postulate that precisely 0 idiots wrote it. I suspect when the function was first written, it was quite innocuous. May have never even intended to have been released. I don't know what the story is, but nothing wrong with this. We're adding innocuous data. And then it proved to be useful. There's nothing so dangerous as useful code. So we start putting more useful information. And then more data gets added. More data, because we need more stuff to work out, especially with this application. I cannot overstate how bad this application was. Until one day we're dumping rather more information than we should be, and just all the data is going out there. And that's not the only way that this particular story could have unfolded. You've also got this example where your session only has innocuous data in it. And then someone goes and puts some sensitive stuff in there. And because these 2 bits of code live in entirely different places, you have unintended consequences happening that you were not aware of. There is a whole load of context that is missing from this story. This story started near the end of the book. This is chapter 17, watching the world burn. Okay, we're back here. Func name returns a string. Name returns the name. Actually, let's make this more realistic. We're going to make this into a struct. Go use as structs, very C-like. We can use that for data, and then we can hang functions off those structs. So we've got a person, and they have a name. Let's add some documentation and make sure that the linter is going to be happy with it. So we have the person type. Linter's going to be perfectly happy with that. And the name of the person. Linter's going to be perfectly happy with that. They are descriptive, they are accurate, they are bollocks. To be honest, this documentation is not worth the screen real estate that it is taking up. And I've got questions. What can be in that string? Anything, I guess. Okay, so name contains an arbitrary formatted string representing the moniker for the person.
I found this on the web.
I don't care. For the benefit of the video, my watch decided to pipe in. This is better, but I mean, personally, this still needs more. And given I'm making up the specs for this particular application on the spot, as I go through, let's add some extra documentation for the specs. So a person describes a character in a book. I'm really looking at this and going, right, we've got the wrong words here. We can get better words to be used. We could have a character. Now it's just a character in a book. Did you have a... Comment from the audience, book character. Yes. However, with the way that Go works, this would probably be in a package, and you'd probably call your package book. So when you're using it, it will be book.character. But if your language doesn't have that kind of semantic, then perhaps book character would be a good idea. And if you're using Java, then of course abstract book character factory implementation would be also perfectly acceptable. So, we could do more with that. I'm sure we could. Let's ask ourselves a few more questions and just see whether that helps drop some things out of here. Let's go see what else we can ask. I'm making the specs up for this on the spot. Name cannot be empty. You will never get the empty name back. And then some programmer is going to come along and go, oh, really? And in Go, the default value for a string is the empty string. And the way we've created our character, it has a default name. Name is empty. Name can be empty. I mean, you can be as insistent as you like in that comment. You could even make the cannot be in capital letters. It's still going to be empty. And not only can it be empty, it defaults to empty. That is its default state. This is not going well. Right, okay, what's going on here? We've decided that we need to hide name because we don't trust developers. So we've made name a lowercase, and that's now private to our type, and you access it via an accessor function, name, which has been associated with the character type, and name does a little check and says, if it's empty, I'm going to return the default name. Otherwise, I'm going to, well, actually, if it's empty, I'm going to set the name to the default name. Otherwise, I'm going to return the name. And now, the comment is correct.
Almost.
Name will never be empty.
Only for the person.
Thank you. Damn it. I changed these slides last night. It used to be the person type. Code review. It's important. Correct. Moniker for the character. That should be character. Again, for the benefit of the slide, I have made a mistake. It's not the first I will make, certainly not the last. Can anyone else spot some issues with this code?
You have a getter that is setting the name.
Yes. It's worse than that, actually. When it sets that name, because of the way the Go works, it never gets propagated beyond the call of that function.
What?
This particular function acts on a copy of character. So it gets a copy of character, makes the change, and whatever character you have still has. You will always get the correct name back when you call name, but it's going to be doing that set. So that's a bit of a thing. But the other thing is that name is now entirely private to the scope of that character. And this is in a library. If this is in a library and I can't actually reach in there and fiddle with name, I can only ever have the default name. I can't set the name. I would say that's broken the code somewhat. Documentation's much better. Code, So, constructor function instead. Now, we don't have objects in Go. We have types and structs. And we don't have constructors per se, but we do have this kind of idiomatic constructor function where we say new type, and that returns your type. So this is very idiomatic within Go. There is a new keyword, but that in itself is an entirely different talk in the way that Go handles creation of new variables and new types. And the simplicity thing, due to combinatorial explosion, takes a flying leap, and there's about 40 different ways to create a new variable. Anyway, so now we can create our new character, and we can be sure that when we call name, that character's name is going to be set. Good. Job done. Right. Wrong. We can still bypass our check because it's not a proper constructor function. I can just not call it. I can still just create the default empty value of my character. Hey. So this isn't going to. And apologies, the code is getting a bit small because there's now quite a lot of it for something that just returns the name. We're getting a lot of code there. So now I have the check twice, and I still have issues with this code because, as has already been pointed out, we're setting the character name in the getter, and we're effectively doing the same thing twice, and there's another discussion to be had here. Should this be returning pointers to this particular type? Should I be using an interface? Should there be some kind of check function that goes off and populates things if they're not created properly? I don't know. Let's have a discussion about it. Let's have a talk. Let's capture what's happened with that discussion so that we know why I have made the decisions that I have made. Okay, in my past life, I decided I was going to write the perfect name, actually the time class, it was in Java at the time. It was going to be a thing of beauty. It would handle all names everywhere and be perfect. There are some issues here. There are some big issues. Title and forename and surnames and suffixes and middle names. There's actually prefixes. There's name order that we need to worry about, because actually it turns out that not everyone goes first name, surname. Sometimes it's surname, first name. And then you've got other things that really start breaking the assumptions in this, like Madonna. She only has one name. Jennifer Null. This is a valid name.
It's an actual person.
It is an actual person. It's where I got this name from. Jennifer Null should be allowed into a system. Names can be null, even if it's the string null. What about someone with a single letter for a name? What about someone with an emoji in their name? What about someone who doesn't even use a Unicode character as their name? So, prints aside, because seriously, just use a string. Names should be a string. And arguably, you could put the SVG for this symbol into that string. Or just call him artist formerly known as Prince. And that's not all. We can make no assumptions about the contents of that string. This is a valid capitalization for the name MacDonald. This is valid capitalization for the name MacDonald. Do you want to know how you work out which one is correct? You ask the person. They tell you. There is no programmatic way, short of going, "What is your name?" and then accepting the answer they give you. So why don't we do that? And also, let's actually encode this hard-won knowledge. This project to build the perfect name. Okay, it was on the train, but it was 6 months before I gave up. Then, even more foolhardily, I went off to go build the perfect telephone number function, object. It's even worse. Then I went and did the perfect address one. Then I stopped doing names, addresses, and telephone numbers entirely. We can encode all of this. Name returns an arbitrary formatted string containing the moniker for the character. I fixed it there. Name will always be populated, but may be the default name if no name was provided for the character. No assumptions can be made about the format regarding case, title, number of names, or order of the names. It can be assumed that the name can be displayed as is. Fair amount of information, got a lot further from name returns than name. And ooh, we can assert some of these things. We can prod these with tests. Unit tests are often overlooked as a method of documentation. They can end up as a garbled mess of setup and tear down to coerce the application into the correct state, to prove that, yes, this one set of bizarre situations causes the correct thing to happen. This is actually real code. I did write it. And all of this tests this one function call. It's absolutely ridiculous. This is just pure gloriousness. Suffice to say, I had some big conversations with the driver writers for this particular package, because I didn't need this in my life. And this is actually quite tame compared to some of the tests I actually had to mock out. For context, I'm getting stuff returned via JSON, and the JSON format is quite arbitrary and quite complicated, and I'm having to mock out responses from the database, and it was all very not fun. So Go has a number of different formats for tests, and one of my favorite ones is the example format. The example format will actually go into the documentation, and I quite often use the example format for my positive case. So it's an example of how you use the function. It's like, how do I use this? What does it do? What do I expect it to pull out? And it gets to pull double duty as both a test and usage of the code. And if you go back to where I was using the toTitle function, if that had had an example, it wouldn't matter that I misread the documentation. I would have seen straight away that if you put in Word, you get all of it capitalized. And I would know that that is not the correct usage. So, I mean... very interesting. Can anyone hear us? I don't know what's going on there. We have a ghost in the room. So this particular test doesn't do a huge amount, but it does produce my positive test case when I get the name. Is it the name that I passed in? Yes. And people can now see what's going to happen if I call a name. So, our code's better, our documentation's better, we've got a unit test that's there to bolster it, we've got some story emerging. Let's put this into Git before we get too much more. So we're going to add it to Git, git add dot. We've got two files that are going to go in there. We're going to commit our code. Bam! Add character type and test. We were doing so well. I would argue this is not much better than initial commit. I mean, this just duplicates what the commit actually is. Now, we could possibly flesh out the message a bit more, and perhaps there is a cause for that. Git allows us to put much more information into that commit message. If you've read the articles on how to best format a Git commit message, you treat it like an email. The first line is your subject, blank space, and then you can write War and Peace if you want to. But we may actually have all of this information stored somewhere else. And I don't like making work for myself. So we can do this. And now my commit message points to an issue in my issue tracking system. And certainly in Bitbucket, I'm guessing GitHub as well, you can get those systems to link to your issue tracking system. So off we go. So more detail is just a click away. And that's actually live detail as well, because if you've had a discussion beyond when this commit happened, it's captured there. So, fix issue number 42, add character type and test as per spec. Implies there is a spec that we can go off and grab. And because it's in the issue tracking system, we can capture the discussions about it. And also, there are other ways that we can capture discussions with the Git process. There are conversations to be had about, should we be using pointers, should we be using interfaces? How do we deal with this fact that the name needs to be set if it's an empty string? All of those discussions can be had, and because I don't have answers for this, I can go call on my colleagues and go, Peter, how would you fix this? How would you make it better? We can have that discussion, and I can take his knowledge and apply it into the code as well. Great. So this is from my GoBase package. I'm a team of one, so the discussions are not huge. The commit just says remove setup target. Because I removed the setup target from the makefile. But it references the issue, and the issue does have a little bit more information about why I'm doing it. It's all covered in the build image, and I don't want to make assumptions about the local build. So there is a link there. There's a little bit more context. So this is beefed up. It's been added to source code control. It is ready for code review. Although I much prefer the term pull request, because it's not just about the code. It's a crucial step for all new code. For starters, it helps spread knowledge about what's going on.
Message passing from advise.
And now we've got the tech people coming in because there's even more sound coming through. Sliders have been slid. Buttons have been pressed. Things have been turned off. A lot more noise, and you wouldn't be here. Just make sure that well, okay, we're good. Let's continue. Yes. Your pull request is a way of spreading knowledge. So you can talk through what you're doing with others. I already said I love doing this with junior developers because you've got to actually explain your thought processes. And when you say them out loud, the lunacy and the stupid assumptions and all of that stuff come to the fore. It also increases the number of people who can tell the story of the code. There is the classic bus test. What happens if someone gets hit by a bus? And it can be anything. It's like, what happens if they decide to move on to somewhere else? What happens if they're ill for a week? These things happen, so spread that knowledge around so you're not reliant on one person. And it helps spot mistakes. I've got lots of eyes looking at my slides. I've read a few times. Mistakes were found because another set of eyes, fresh to this problem, spotted the mistake. And it wasn't a mistake in the code, it was a mistake in the documentation. Now, there is a school of thought that says you shouldn't document your code because the documentation goes out of date. And now your code and your documentation are out of sync. And I've never really understood this argument because you've got 4 potential situations. You've got code, you've got documentation. They all form, I'm talking about documentation in the code, they all form part of the source code that goes into Git. So they're going to be part of your pull request. So either the code has changed and the documentation has changed. Let's check that both are sane and that they agree and that we're happy with both of them. Or your code has changed and your documentation has not changed. Let's make sure that the code change is actually fixing something because the code is doing something that it shouldn't have been doing and the documentation said otherwise. What we're doing here is we're fixing a bug. Maybe the code hasn't changed, but the documentation has changed. Here we're fixing a bug in the documentation. My earlier slide, we would want to go in and change that particular document so it says character, not person. There doesn't need to be a code change. We're bringing the documentation in line with the code. Now, the 4th state is not what you might think it is. This is not the 4th state. This is not a pull request. This is nothing. Nothing's happened. There's nothing to do the pull request. This is it. The code has changed and your documentation is broken elsewhere. Ergo, documentation is bad because it goes stale. No, I disagree. Categorically, if the code elsewhere breaks, well, if our code changes break, documentation changes elsewhere, then we have incorrect assumptions about the code. Because if our unit tests haven't picked up that the changes of the code have made changes somewhere else, then our unit tests are not full functioning, and we have assumptions baked into our code. So not only has the documentation gone stale, but the code has also gone stale, and we've got some incorrectness in there. And the problem doesn't stem from the documentation. The documentation here is not the not the cause, it's a symptom. And if the unit tests do break, then we need to update them. And we're looking at that part of the code base, and we're updating the code, and we're updating the documentation. So we're back into our code and documentation has changed. And it takes us back to a scenario where there has been a code change and there has been a documentation change and everything is good. So it's not about documentation, it's about the system as a whole. Code is just one often tiny part of a change in a system. The change is everything supporting that code. It's the documentation, it's the tests, it's the commit messages, and anything that might be linked to the issue we're currently working on. This is an incredibly innocuous change, but has a huge impact on every single repository I use. Because this is the base package for everything that I set up. Let's have a discussion about that. And yes, my unit tests will fail if things go wrong further downstream. This should all be a vast and rich body of work telling us the story of the code change, and a story that can help us when it comes to spelunking at a later date. Code archaeology is never going to go away, but we just want to make it a lot easier. And the pull request should be focusing on all of that. We should be understanding the context behind the change and what's gone into the change and what were the discussions they had. And it's hard to do that if your change is hundreds and hundreds of files and thousands of changes. You go code blind. Little and often, little and often, little and often. Even if it's not a complete implementation, break it down into smaller chunks. There are loads of different ways of doing it. There are loads of different processes. I'm not going to mandate that you should be doing one thing over another thing. Just do things in smaller chunks. Work on them one at a time and review. Build that story up. Even if you're a team of one, I mandate this process on myself because it becomes a lot easier to actually spot things. You're going through the process, you're reading things, you're double-checking things. Are my assumptions correct? Do something nice for Gail. She'll give you a tiny little duck that you can put on your desk and talk to. It's very simple. So our change is small, it's compact, it's easy to digest. We can read the documentation, we can see what's been asserted, we can ask questions, we can state that we need more tests, we need to think about how this code's been written, we can go back, we can change it. This is not the ending to this particular part of the story. Is this the best way to handle blank names? Should there be a helper function? What should we be doing? And through all of this, we've just been looking at sensible data because that's what we tend to do as programmers. We look at the sensible side. But what if things are a little bit wonky? What happens here? What should happen here? Should we keep the spaces? Should we not keep the spaces? Are they important? There's a discussion to be had there. What about this? Is this a blank name? I don't know. Let's have a discussion. And this may involve going back to the product teams, speaking to them. There's this bizarre edge case. What do we do with it? Then we encode that knowledge, and we test against that knowledge. This, if you were in the belief that we shouldn't have comments, we shouldn't have documentation, this may have flown through code review. Because this is simple. It's easy to understand. There's no story, there's no context, there's no questions. Done, through. This raises questions. And those questions go on to enhance the quality of your code. They build on its story and they enhance the quality of your product. Now, it is said that there are 3 hard problems in computer science. Number 1 is cache invalidation. Number 2 is naming things. Number 3 is exactly once delivery. Number 2 is naming things. And number 4 is off by 1 errors. Naming things is stupidly hard. This is perfectly valid Go. It's calling the function config on the config type in the config package. So config, config, config. So we're doing stuff with config. Pretty sure of that. But we could use the semantics of the language to tell us so much more. And this comes to your statement about, what about book character? The names themselves can actually tell a story. So we can infer that config is in fact a global variable. So we could call it global. Let's just be explicit about that. And I'm not entirely sure about the package name. I don't know. Is the configuration provided here or is it parsed and stored here? What's going on? Perhaps settings may have been a better name. I don't know. I'm just spitballing. But we've already got more details. It's our settings package. We have a global config and we're getting that global config. And we might want to start asking questions. Do we really need global config? Should we be having global stuff going on here? Perhaps we can pass the configuration into functions that need it. Perhaps we could be using a context. No, there's a conversation to be had here. Other languages have their own semantic foibles, and you can use these to your advantage. Because ideally, your code wants to read like prose. You want to know what's going on because there are sentences effortlessly falling out of the code. Dense, impenetrable code is an absolute nightmare to read. Now, I speak pretty good regex, and I've discovered that not many people do. So if I do use a regex in my code, there is generally a comment like that above it that says, this is what it's doing step by step. Because I cannot make the assumption that you speak regex as well as I do. And even I look at this and go, I may need to sit and think about it. It does email validation, incorrectly, by the way. There is only one way to validate an email address, and that is to send an email to it. I'm sure it's very clever. But clever is not helpful at 3 a.m. on a Sunday morning when the server is dead and I'm trying to work out how to revive it. I don't want clever. Been there, done that, got the t-shirt. I like simple, I like easy to read, which is why I like Go so much. You'll notice this is not Go, this is JavaScript. But it could so easily have been Go. One of the things I do is I've stolen Kevlin's FizzBuzz fix, which uses an implementation or a fact that the random number generator at a particular point with a particular seed gives you a sequence that allows you to look up the correct values for fizz and buzz in a slice that you can then index and pull. It's horrible. And I think it's like 10 lines of code. And I fully encourage people who are doing interviews where you're told to do fizz buzz to produce something like that in the language that you're doing it in, just to show that this is actually a bad discussion to be having, and let's talk about writing decent, understandable code, not just nailing the spec. So, what have we learned? What have we learned? We have learned that we suck at comments. Hurrah! We suck at documentation, both writing and reading. Both sides of it. We suck at git commits. We suck at naming things. We suck at software development. And writing code is just one tiny, tiny, small aspect of that. But thankfully, telling the story of the code helps us get better at this all of the time and helps us become better software developers all round. It's going to help us get better at these perfectly natural human failings. We'll start by assuming that the users of our code are real programmers. Now, we'll accept that they don't need documentation or comments because they are real programmers, and we'll accept that they don't eat quiche because they are real programmers. But we're going to give them half a chance. And we're going to give them the comments and the documentation and the context. We're going to give them good semantic names for everything, not because they need it, they're real programs after all, but because we want to make their lives easier. We want to let them have time to spend on other things, like discovering that quiche isn't that bad. But naming things is hard. Well, yes, but good semantic names become apparent if you're just willing to change your names, possibly quite a lot, and to tell a story with your code. If you are producing things that require linguistic hurdles in your function calls, in your documentation, the name is probably wrong. A good name will drop out of the discussion. So we can start off with type thing. Thing is actually perfectly correct. It is a thing. Whatever this code is, it's a thing. And we're going to do an action, and that's going to return an int. An action is correct. We are performing, we're calling a function, it's doing an action. But, you know, thing is what? Action does what? Let's be more semantic about this. And the Go format for documentation is actually quite brutal here because you've got to use the name first. And I like that. So we've got to say thing is, and we need to say action does. And operation is a single operation on the system. Again, it sounds like Captain Obvious is obvious. We're doing linguistic acrobatics to achieve this. So we're writing fluff. And the odds are that this fluff is poor. Imagine you're explaining this to a junior developer. Operation is used to provide the context around a request made to the system. Okay. I see a better word in there. Context of a request. Each request is given a context with a unique ID. Data surrounding the request is stored in the context. That's way better. Let's keep going. Let's describe what happens in egg cases and what our assumptions are. So here's the ID of the context. The ID will be unique and is static. We may find a better name drops out of this. So, you know, we're talking about our naming. It's a unique ID, so why not call it UUID? The UID is set when the context is created. We can test things. We can test that it's not empty. Does this code scan well? When I'm using it in the package, when I start putting my package names in front of it, does it scan well? Does it read well? Is this test actually useful? Because that's another thing, is just testing things because testing things. Can we describe what we've been done in the commit message? And remember, the first line of your commit message should only be 50 characters long. So you're going to lose some of that if you're putting an issue number in there. So you need to be concise and pithy. And if you can't be concise and pithy about what it is you've done in that commit, perhaps you are committing too much in that commit. Could it have been done in smaller steps? Could you have done more commits rather than more in the commit? And have you made notes? Have you made thoughts, captured those as you went along? Have you made those available to others in a way that is easy to find in relation to that code? Where can you find it? Does everyone know about that? Is it kept up to date? Excellent. Your code now has a good story. And in a few months' time, when something goes wrong, because it will, and somebody's looking at it, hopefully they will not go, who the hell wrote this? They'll look into the story of the code, and they'll find out what assumptions they've missed and what had to change in the interim, and then they can update the story. And I won't have to swear about anyone at 2 a.m, ever again. And I can live happily ever after. The end. Thank you very much.